So why don't we jump right in? Yeah.
So let's go. Yeah.
No, I was going to say, like, why don't you start us off with why, right? Like the why of it, which is like
exactly. Yeah. So the most common deployment that we have with Yugabyte with a distributed database is in the cloud, in a region, in multiple availability zones, because that's the idea. With 3 availability zones in a cloud region, we have redundant power, networking, connectivity, so that when one zone is down, we can continue. The idea is that the database in production is deployed with a replication factor of 3, which means that one node can be down, one availability zone can even be completely down, because we have replicas everywhere. And this works quite well without problems with performance, because the cloud providers make it just a few milliseconds latency between the availability zones. So the distance is calculated to be far enough not to have the same risk of failure in case of earthquake, for example, but close enough to have low latency. And that's the idea. And
yeah, it also reminds me of actually practical instances where, like, for example, there was a snowstorm in Texas, right? Like in the US, I think maybe a year ago or a few months ago. And that caused an outage of power throughout many portions of Texas, right? And that took down, or I remember, like, there was a fire in one of the buildings in, like, one of the data centers. I think this was OVH Cloud or something. And so these occurrences are just like, act of God, right?
So for OVH, for example, it was only one availability zone because it was different data center, but just close together. And then the fire touched multiple data centers. And that's also why we need to go further than this configuration. So basically with that, we can write in sync to the quorum so that we are sure that we have at least, we write to the leader. Each table is split in tablets, as we have seen in previous episodes. And each tablet in the Raft protocol as a leader, and we write and read to the leader. So this is distributed because rows are distributed into multiple tablets, but for one tablet, we always read and write on the leader. And for writes, the leader ensures that the writes is propagated to the majority of followers. And this is how we can avoid stopping the database if one availability zone is down. So RPO, we don't lose any data, and RTO, the worst that can happen is that there are leader elections that can take 3 seconds. But with this deployment, there are some considerations that maybe are not covered there. First, even if availability zones are distanced by a few kilometers, the same disaster may happen in a region. Low probability, but you don't want to lose data in this case. By disaster, I mean, it's not only that everything is stopped for a few minutes, it's that maybe a fire is so wide that it touches multiple availability zones, and then data in this place can be lost. So there is a need for disaster recovery in this case beyond the region. And there are also short failures that can happen for a whole region. And also we have seen that recently with AWS, and we have seen that also in different cloud providers. Sometimes, even if everything is redundant, the whole region is down. And there is also the case where you don't have 3 availability zones. So here I mentioned on-premises deployment, because most of the companies that have multiple data centers that can be in sync, so with low latency, they usually have 2 data centers, not 3. The third one is further, and then we need another solution for that. But there are also a lot of cloud regions where there are only 2 availability zones, or where there are failure zones, but in the same data center, and then we can have a risk in that. there are also other regions to go beyond the region. We have users that may want to query from another country, and then we want to put data there. And there are also some legal reasons. For example, there are laws where European users, their information must be stored in Europe. And I will show quickly then what can evolve from that. So the idea going to another region is, for example, putting what was in a third availability zone, putting it in another region. And then the latency will be a bit higher. If we do that, we do not suffer from the latency because we have only one follower elsewhere, and then the quorum is still low latency. However, there are no big advantages to do that, because in case of a region failure there, I have only one follower, and then I'm not sure that it got the last changes. So the idea in a multi-region deployment is to have zones in regions rather than zones. So nodes in the different regions. So probably the opposite. We want the closest region where the latency may be, say, 20 milliseconds, and maybe a region a bit further with hundreds of milliseconds. And then in this case, the reads that I will do on the leader are still fast, but the updates will have to wait for the quorum of the first one, which is probably the closest one. And this is the configuration that we will see in the demo that I have prepared.
One question, Frank, from Ashish, right? Like, is if you can differentiate between how YugabyteDB works with established data protection methods such as active data guard, right? Like with Oracle. So if you can also at the right time, right? Like at the right time.
Yeah, exactly. I can do it while we are there, because when we see that leader and follower looks like an active passive, but those are not databases. Those are shards of tables or shards of indexes. And then even if some rows are updated in a leader, other rows of the table will be elsewhere. And here in my diagram, I connect here, but we can connect everywhere. And I will show that in the demo, because we will connect everywhere. I've set up a cluster, and I can show you.
Also, I think the other interesting thing, I mean, as you're bringing it up, Frank, is also the schema management, right? Like the schema and the DDLs can be applied from anywhere and are consistent across the.
Yeah, exactly. Yeah, we will create a table. Let's just go to my cluster. Here, we have a lot of databases there. So I've set up a cluster with 2 nodes in Europe and 1 node in US. And I can see the nodes there. So this is on AWS regions. And
maybe you can make it a little bigger, Frank, if that's okay.
Yeah, I will.
Yeah, that's
but
good.
The best is to connect to it. So I am connected there. I have put in the prompt where I'm connected. So I have 3 sessions, one that is connected to Ireland, one that is connected in California, and one that is connected in Frankfurt in Germany.
So maybe even before we go further, Frank, I think there was one question from Kurt, which is inter-region replication sync or async?
Here we are talking about sync replication. So if I just show back the diagram there, here we are all in sync, which means that when I write here in the leader, I wait in sync for the quorum of it. So I'm waiting to be sure that it went at least to the majority of followers.
Yeah, so we use a consensus protocol called RAFT, right, to replicate data. And that means you'll have to write to a majority, in this case, 2 out of 3. And I think your point is you write to the nearest 2, which is the leader itself and the nearest guy. And that makes sure that even in the failure of a data, your data is synchronous and you don't lose anything. Your RPO is 0, as you showed in the previous slide.
And then with the failure of a zone and or a region in this case, we can still continue to take reads and writes. So here I've queried an internal view that shows the configuration. So in a production cluster, we have more nodes. We have many nodes in each region. Here, only one in order to see clearly what happens. And I will create a table.
And you're creating the table by connecting to the US West region, right?
Here I was connected to Frankfurt.
Central, got it. EU Central. Got it. Okay.
I did it on purpose because I don't think we will have time to talk about the master, which has the catalog. But
that's okay. That's okay.
The catalog is nearby, and then DDL may be faster. So I've created the table. I can check the structure of it. It's just a really small table, and I will insert a few rows connected to another place.
EU West. So you're inserting from a different region now, right?
Yeah, exactly. Logically, we have one database.
Yep.
So here are my 6 rows, and the idea is to query, and I will query it from all places. And you already see that some places are faster than some others. And I will show the execution plan with the timing. Sorry, I have to copy paste from there. So I will query here only one row ID 1, from the 3 different places. And I do it several times with watch to be sure that we don't have cache effect in IOs behind that. And the first thing that I want to show is that, so yeah, first there is one thing. I'm connected from Switzerland. So of course the elapsed time may be longer. The application should be connected on the closest nodes. And this is why I will not look at the elapsed time. I will look at the execution time.
Yep.
Because, for example, if you connect, you are in California, Karthik. So if you connect, you will see different picture for the elapsed time.
That's right.
But the execution time is executed on the node.
Makes sense.
Then here for the row number 1, so table is sharded, rows are distributed, but one row has only one place, one tablet where there is a leader and followers. So row number 1 apparently is here in California, because from California, let me check. Yeah, from California, the latency is low. From the other places, the latency is higher, which is the round trip between Europe and California. And if I run the same for another row, we will see a different picture, because by default, we distribute all rows, and I've created the table with hash sharding. So a different row should be should have its leader elsewhere. Row number 2 here is probably as its tablet in Germany.
Yeah.
And
it's also interesting to note that, like, as you're running this this query from the one above, what is that? Europe West, right? Dublin. The Dublin data center is actually 23 milliseconds, just the way you drew the diagram, right? So,
yeah. So when I read here, I just read from the leader. So depending where I am, the leader is in the same region or in another region. And now what I will show, because we cannot change the latency. That's something depending on the speed of light and the internet infrastructure. So we cannot change it. But what we can do, we can change the topology. And here, for example, I will show that if all my users are in Europe, or most of my users are in Europe, I may prefer to put all the leaders in Europe. So let's do that with a preferred setting. I'm not sure that I validated it. No. Clicking too fast. Because doing that, of course, there is some rebalancing of the data in behind.
Rebalancing of just the leaders, right? Data stays where it is. It's just the leaders.
Yeah, exactly. Yeah. Data is still at the same place. And here we will see that by putting that, and I can also show the tables. If I go to the master, the GUI of the master, and I look at my table, I can see the leaders. So this rebalancing has been done because I see all the leaders on the same node. And we see the placement info. This is the placement for that table where it can go in all regions, but with affinitized leaders. I've changed it at cluster level, but we can also change it for specific tables with table spaces. And here I check the information from each table. So here now, row ID 1 is fast from Germany, and that should be the case for all rows because all the leaders are there. Okay.
Yeah, and this clearly shows. Yeah, and now I think row ID 2, every row should be fast.
Yeah.
Right? Yeah.
If I select all rows, the query where the leader is fast. Dublin is not so far. Sorry, explain, analyze. And it takes more time because round trips from there. Those are about reads. With reads, we care for the latency aspect, we care only about the leader. But for writes, we have to wait in SIG for the quorum. And then I will run some updates. So now I have the leader in Germany, and I will run some updates several times just to be sure that I have no cache effects. And you can feel that it takes longer when I'm connected to California. So for the writes, I can see 25 milliseconds there. And this is not the latency for my local regions. We have seen that for the reads, it was lower than 1 millisecond because the writes have to wait for the quorum on one of two. And obviously, Ireland is faster to answer than California. And then the latency to go to the follower in Ireland is there in the write latency. And doing the same from Ireland here, I am in Ireland. The write goes to the leader in Germany, and this leader has to get the acknowledgement from Ireland. And this is why we have 2 times the round trip. And of course, from California, we have the round trip that go further. You tell me if we have questions.
Yeah, I think maybe a couple of things that like I can ask, right? So in this scenario, and we can just like talk through it, right? Like in this scenario, you have all the leaders in Germany, right? Let's say the Germany data center fails, right? Like this is what this is about anyway, right? So yep. What will it look like now, right? Like maybe we can use the preferred region thing to show, or if there's a way to show it, right? Like I'm guessing.
I think I can
yeah,
stop it and we will see.
All right, it's like let's do it. All right, so this is a live DR scenario where we've taken down the Germany data center, right?
Yeah.
So, yeah.
So of course, here I'm connected to Germany. So if I run my query again, I don't
it's
think
still going to route to somebody else, right?
I don't think it's stopped yet.
Oh, it's stopping. Yeah. Okay.
So I suggest that we go to the slide and we go back there because the stop I did.
Yeah.
The stop I did maybe is not immediate. I don't have a kill there. So let's stop it and we will see. But basically what happens is that there is a re-election to get all the leaders elsewhere and then latency. So we will get back to it to see what happens after that. And what I wanted to mention first, we are talking about latency. Here we see the latency on a few queries. But when we go cross-region, the latency is less predictable because it depends on the global infrastructure of the cloud provider. And first, I've put a link in the slide. There is someone who collects the latency between the AWS regions, and you can have the percentile. And this can be useful to set up the topology, knowing the average latency of it. And what I wanted to mention also is that we have the possibility also to have faster reads, even for people who are not close to the leader. So either they read from the leader and they have this 100 milliseconds latency, or they can read from a follower if they accept that they don't see the latest changes. Because the followers, if they are not acknowledging the quorum, they may lag, but they will be updated because the leader sends it to all followers. And then if we accept, for example, 30 seconds latency for reporting, we can read from another region, setting the transaction in read-only. But I think we will have other episodes about that. And
so effectively, I guess what we're saying here is there is to deliver ACID transactional semantics, right? There is like a latency trade-off when you go to faraway regions, but you can mitigate that by moving leaders close to the application and still get good latency while not giving up your DR, right? Like ability to survive failures. But there are other techniques where you give up consistency and then improve performance. Right? That's essentially what you're trying to say. There's a number of techniques, and you're saying, yeah, got it.
But those follower reads are still consistent as of a point in time. It's not like eventual consistency where you may join tables that are not consistent because they didn't get the same change. This is consistent as of a single point in time.
Got it, yeah, because the database is frozen as of some older snapshot and it reads from that snapshot, right?
Yeah. So let me see if it stopped. Yeah, it stopped. So I was just not patient enough. So the one that was connected to this node, of course, cannot reconnect. And here I connected directly. I don't have the smart driver. So this one cannot connect to this region. The other ones, if I run them, they see the data. But so this is an update, but I can even run a select. Where did I have select there? Yeah. So here the leaders went elsewhere because the preferred region was not available. And I can see that ID1 is in Ireland.
Yep.
Let's check ID2. ID2 is probably in California. So from there, ID2 will be faster. So we have a preference, but of course, the database continues even if there is a failure, because probably this failure is just transient. I will restart. I don't think we will have the time to see it. But what happens in the cloud, it is rare that this kind of failure takes hours. So then everything will be rebalanced and put back to the preferred. Sorry, I'm clicking the bad one, start process. So when this one will be started, the preferred, the leaders will go to the preferred zone.
Got it. And it'll go back to the same setting which respects the preferred leader, right? So your latency will go back down.
The idea is that all that is automated. This data sharding is all automated. There is above that the possibility to put data where we went with a declarative way using table spaces. For example, I decided to put all leaders in Europe because all my users are in Europe and maybe only reporting in US. But what I may want to do is put my European customers in Europe, my American customers in America. And then in this case, I have a column in my table, which tell me the country of my users. And then in this case, I can partition that and put the partition, map the partition to the table spaces, and the table spaces are mapped to this topology. And then I can say that this partition will have preferred leaders in this place and another one. So those are probably for the next episodes, where colleagues will explain them. We have many different possibilities. The default is distribute, but when we are multi-region, we have to think about where to place data and where we are doing the reads and the writes. And then we have multiple things. We mentioned the reading from the followers. We mentioned the partitioning. And there is also the possibility to add nodes that will be only in asynchronous, so more like asynchronous replication for reporting elsewhere, but then they will not be in the column. They will not help for high availability. They will be there just to have faster reporting, for example. And we have also logical replication in that.
Makes sense. Awesome. So there's one question from Kurt, which is the Raft consensus based on agreement on the point that PostgreSQL streaming sync replication has been applied at each site?
Okay, yeah. So we are Postgres compatible. We use Postgres for all the SQL processing, the query layer. But this Raft protocol, the tablets, this distribution is in the distributed storage and transaction layer. And this is not Postgres. This has nothing to do with Postgres replication, and we don't use the wall from Postgres. We have walls, of course, in each shard, but this is different from Postgres. We connect to it as Postgres, but behind it, because there are many tablets and all this is distributed, this is not the Postgres part. Actually, yep. when I insert, read, write in those rows, instead of going into tuples in heap tables or B-tree indexes, this goes to the distributed storage.
Yeah, so yeah, I think Radek also answered that. So effectively, Kurt, the lower part of the system is completely new and different from Postgres. So the replication uses Raft. The Raft doesn't wait to acknowledge the replication. Raft is the way replication is done. So yeah. Excellent, awesome. Other questions? I think we're at time, folks. So feel free to join us on Slack and pop into the YFTT channel to continue asking questions. We'd love to hear from you. If there are other topics you guys are interested in, let us know. And once again, same time, same place, I guess next week we'll have another topic. So thank you, folks. Thanks, everybody.
I think it's about follower reads.
Follower reads, that's right. Very relevant topic as well. So yeah, and thank you, Frank. An excellent presentation, and thank you for putting up with taking down regions on the fly and already adding to an already live demo. But it was fantastic. So great.
Thank you.